Hey everyone, here's part 2 of my workshop on virtual machine clustering and setting up MPI. Now in part 1, I focused on the virtual machine clustering aspect of the workshop, and I talked about how to connect two virtual machines and how to set up an NFS server and client. Now in part 2, I'll focus on setting up MPI. Now, with that being said, if you haven't seen part 1 yet, go to the description, watch part 1 and set that up because it is a prerequisite to part 2 of how to set up MPI on virtual machines. Now we have CentOS-1 and CentOS-2 connected, and the first thing that we do is we need to be able to SSH from one machine to the other machine. SSH is a way of remotely jumping from one machine to the other machine. For example, if I SSH root at the IP address, I'll jump to this IP address. So 10.0.1.3 is the IP address of machine number 2. By doing IP addr show, I can see the IP address, and it is 10.0.1.3. So I just hit enter. And I have to hit yes for this prompt, and I have to enter my password. Now I'm on CentOS machine number 2 from CentOS machine number 1, and that's all SSH does. So I'll exit to get out of CentOS machine number 2, and I'll be back on CentOS machine number 1. Now, when we SSH, we usually have to input a password, but for MPI to work, we don't want the password prompt to come up, because when you use MPI, you need to have complete access from one machine to the other machine, and we can do that via SSH keys. So to set up SSH keys, and what they actually do is that they provide key access from one machine to the other machine without a password. So as long as the key verifies that this key gives you access to this machine, then all you need to do is have the key on one machine to access the other machine. So the first thing that we do is we have to make the directory, and the directory that we'll be creating is in tilde/.ssh. You might already have this folder, but you should make this the directory if you do not, and you hit enter. And it says that cannot create directory because it already exists. Sometimes it does not exist. So now let's just check if we have anything in there. So we have a file called known host, and what known host is generated when you SSH to another machine, and it saves these locations and IP addresses and information about where you actually SSH to with the known host. But now what we want to do is we want to generate a new SSH key, a key that gives us access to machine number 2. To do that, I'll be using a direction from GitHub, and I'll leave a link in the blog post. Of course, all of this will be in the blog post, so don't worry if you miss some commands. So I'll copy this command, and I'm generating an SSH key, and I'll place my email within quotes, and I hit enter. Now it's generating the SSH key, and for the rest of these you can leave it by default. You don't need a passphrase, and you can hit enter. Now if we ls within the .ssh folder, we'll see that there are two new files, idrasa and idr_rsa.pub. Now the next step is to copy, or I guess we can copy idrasa.pub to a file called authorized keys. So we're basically copying this file into a new file that hasn't been created yet called authorized_keys. And we do this because you want the key to be able to access this machine. So now what we want to do is we're going to use a command called scp. scp is for transferring files and copying files from one machine to another machine. So the two files that we want to copy are idrasa and idrasa.pub to root at the IP address of our machine number 2, at colon. So it is important to leave this colon at the end. We hit enter. And we have to do our password still because machine number 2 does not verify authorized keys from these two keys that were sent. So if we ls, we'll see two new files, idrasa and idrasa.pub. And we want to move, well, first we have to make the directory tilde/.ssh. And we hit enter. Now that directory is created. After it's created, we can move idrasa and idrasa.pub to the tilde.ssh, and we hit enter. And now we cd to change directory into that folder, and we ls. So we have the keys transferred into machine number 2. And now we just copy idrasa.pub to authorize underscore keys, and we enter. Now we see the new file if we ls again, and now if we ssh root at, if I'm on the second machine, then the IP address of the first machine is 10.0.1.2, and I hit enter, and it says, it gives me this prompt, but I just say yes. Then it does not ask me for the password prompt because the authorized keys from CentOS machine number 1 validates and says that if machine that access this machine has idrasa.pub and this specific idrasa, then give it access. So likewise, I can ssh at 10.0.1.3 and there's no more password prompt. Now I can exit on both of them. So that's the first step because we need to get SSH access without passwords on both machines. Now the next step after this is that we need to install a couple of libraries. So the first thing that we need to install is that we'll install something called wget. Now what wget is, it is basically it's a package that allows you to download files from the internet onto the machine. So we'll use yum install wget-y only on machine number 1 and hit enter. And we'll install this package that lets us download certain files from any link. And this will take just 1 second to download, and then it downloads. Now let's check our shared folder. So on machine number 1, it was in nfs/nfs share. If we ls, we see the text file. On machine number 2, it should be in mount nfs nfs share. We ls, and we still see the text file. So let's, on machine number 2, get out of this and just cd .. it a few times, and we're over here. Now we're gonna move this NFS server, and the first thing when you move the location of the shared folder is that you should first use a command called umount, and then you specify the folder that you want to unmount. In this case, it is /mount nfs nfs share, and then when we do that, it unmounts that folder. And if we go back to that folder, we'll see that it's empty because we're moving the shared folder. So next up is we're gonna create a new location for the shared folder, and when you're using MPI, you want the locations of the shared folder to be consistent across all machines. So I'm gonna make a directory, and I've already created it, and it is /nfs share, and it is in the same location as CentOS machine number 1. So after you create that directory, now we want to change the fstab file that we created in part 1, and instead of on this line where it says /mount/nfs, since the new location on our current local machine is just /nfs share, then we just change it to that, and we do :wq to save and quit. Now if we run the command mount --a, it mounts the contents of the fstab folder or file I mean. And then when we do that, if we go to NFS share, then we can see that we have moved the NFS folder, shared folder correctly. So we do this because, like I said before, MPI wants to have the shared folders in the same relative location on the machines. So after you do that, on machine number 1, we can go back to it, and wget has already been installed. So what we can do now is we can actually get the package. So what the package for MPI is, there are many different implementations of MPI, and what I'm going to use is mpich, one such implementation. So, for example, there are implementations like Intel's MPI, OpenMP, things like that, but I'll use the implementation called mpich. So we use wget, and you can copy this link, but I'll just write it down and type it. And I'm going to use version 3.1.4. By the time this video is out, the version might change. So be sure to check this website to see if there are any latest versions. And I hit enter, and I download it in the location. And so I specifically am in the shared folder, and I download that tar.gz. Tar.gz is just a compressed file format. So after you have done that, now on both of these machines, we want to install some compilers that MPI requires. Now the first thing is we do yum install yet again, and we install GCC, which is C's compiler, GCC-C++, C++ compiler, and kernel-devel. We ended up with a -y at the end. We hit enter, and that will install on machine number 1. And so on machine number 2, we want to do the same command, because all machines must have these packages, and you can just copy and paste them. It might take a second to actually download and install these packages, but just wait a second and they will install. So this is almost done, so I'll just wait it out. It's only a few seconds left. And after it is installed, well, I guess there's an installation period. That'll take a couple more minutes or seconds. And once it is installed, then we'll proceed with actually installing MPI. MPI requires just those 3 packages, at least when you're on CentOS. The names will be different if you use a different operating system. So, whoa, actually, CentOS machine number 2 finished first, but also CentOS machine number 1 finished. So next up, we need to extract mpich. So we do that with a command called tar space -xvf and then the name of the file. And we can just use tab to autocomplete. And then we hit enter. And so this extracts the compressed file to the folder of the same name. So we wait until this is done, and it is done. And we ls and we can see the folder. Now after doing that, we can now, since CentOS machine number 2 is also in the shared folder, we can check that all the contents are correctly inside here. Now we have to make a directory for where we compile the mpich library, where the binaries in the lib folder go to. So we make a directory and we'll call it mpich2. And we just leave it in the shared folder because you want libraries that are used by all the machines to be in the shared folder. So we have an empty folder called mpich2. Now we're going to change the directory inside mpich 3.1.4. And what we want to do now is, if we look, there's a bunch of different stuff. But the order of how to set mpich up is, at first, you normally, when you see all these things, if you see the source code of some C-related program and library, the first thing that you normally do is you use /configure, because there usually is this configure file, and then you can set a prefix to where the contents of the library the binaries the library itself will go to, and we'll put it in slash nfs share slash mpich2. And also, MPI typically uses Fortran, but you can disable Fortran if you're not developing on Fortran or you're not using an application that requires Fortran. So I'll add this extra flag to disable Fortran, and I hit enter. And it configures all of the settings to be put when you actually make the file into that slash nfs share slash mpich2. So it won't put anything yet, but it's providing some configurations so that when you actually make the library itself, it will place the binaries in the lib folder within the specified prefix folder that we had selected. And normally, you select a folder within the shared folder. So we wait until this is done, and this might take a second, so I'll just pause the video just to be not waste your time. So once it's finished, it should say configuration completed, and now you actually go through the process of making the library happen. So the command is very self-explanatory. We do ls again, and we see that there is always this makefile. And what a makefile is that if we open it up, we can see that the makefile runs. Let's just go down a little bit more. Okay, so what you can see is there are a bunch of different commands, and basically it's for compiling the library itself. So we'll just quit out of that. We don't need to mess around, because if you're just setting up mpich, then you don't need to change the configurations unless you know what you're doing. So what we do is we type in make to make the file, and we get started with actually setting up the library itself. So by doing make, it goes through the makefile contents, and we wait until it's completed. So I'll skip ahead with this part as well. So as long as there are no errors, then everything should be fine. Now the next step that you want to take is you want to run make install. Make install finishes the installation of the MPI library, and this should be relatively quick. So I'll just wait a couple of seconds until this make install finishes. And so because we set our prefix and the configuration to go inside nfs share mpich2, everything should be good, and we should have access to it within that folder. So it's done. And so if we go back a directory and we go back into mpich2, we see all the contents within here, several different folders that you did not see before. Now we change directory to bin, and we ls, and we see some familiar binaries. One binary that seems familiar is Mpi Run, and Mpi Run is that binary that was in one of the slides in part 1. Now what we want to do is, if we go out of this directory and we run Mpi Run, we see that we have access to Mpi Run. But if we go to CentOS machine number 2 and we run Mpi Run, we can see that we also have access. Now for you might not have access to Mpi Run, because what I've done already is I've changed a file called /bashrc. So in this file, you want to add these two lines. So we export path equals /nfs share, and basically we write the path to our bin and then colon the $path. And then we also do this for LD library path, because what happens is that when you do not write these two lines, what bashrc serves to do is that it loads this export to provide access to the bin folder from anywhere onto the machine. So I can run Mpi Run as easily as running ls or cd or any other of the Linux commands. So this provides global utilization of the Mpi commands, and I'll leave this in the documentation and in the blog post, but you just copy these two lines and then you save. And then after you save, you want to use source tilde slash dot bash rc. And then you hit enter. Source reloads the bash rc. And you do the same thing for machine number 2. And you make sure that the last two lines have NFS share and mpitch2 with the bin. And then for the LD library path to refer to the lib. And you save that and you do source tilde bash rc. So I was doing that while I had finished the make, and I did that in between the two steps. But just do that, adjust your bash rc, make sure you have those two lines. Now we can access Mpi Run on both machines from anywhere on the two machines. So what's the next step? Well, we have the library installed, so all there is to do is actually run it. So we make a directory called projects inside the shared folder. You also want anything that you run to be inside the shared folder. We cd to projects. And now in projects, we create a file called hosts. So inside hosts, what we want to do is we want to write the IP addresses, including the current machine IP address of where we want the process to be run. And we use the IP addresses of CentOS machine number 1 and CentOS machine number 2. And we save this. So after saving this, we can start using Mpi Run. So if you do Mpi Run, -f is a flag to select a file that has all the IP addresses. So in this case, it's a host file. And then -n specifies the amount of cores that we want to use. In this case, we want to use, let's say, just 4 cores. And let's run an arbitrary program. Like, for example, echo is a Linux command that prints whatever is after it. So in this case, we'll do echo, and we'll do hello world. And we'll hit enter. Now, it says 2 hello worlds are printed, and then we come up with this error where we have to check for firewalls. So we hold control and we press C to exit because the process isn't finishing. And the reason for that is that there are several ports that MPI uses, and those ports range from several different TCP and UDP ports, and this is a networking type of port for packet communication. So what we can do is we can temporarily stop the firewall using systemctl stop firewall D, and we'll stop the firewall. Now when we run the program again using the same line, the packet should be able to send across the machine. So we hit enter and we see that 4 hello worlds are printed. Now a command to check if the process is actually being run is called top. So if we type in top on machine number 2, we can see all the system processes that are running currently. So we see all the commands on the right side in the CPU and memory it uses. So if we run the command again and hit enter, we'll see that nothing changed on machine number 2, because when you're using an MPI run on commands designed for serial, for running on only one machine, then typically you won't see the need for MPI. So MPI decides that it does not need to jump the program to the other machine because there won't be any runtime increase. So I explained in one of the slides that MPI looks for the fastest transport, and sometimes there is not always the case, especially with serial programs designed to run on one machine, that MPI thinks that it needs to be run on another machine. So for instance, doing echo hello world, all it does is it returns hello world. But when we run on 4 cores, it basically runs 4 instances of echo hello world, hence the 4 times it is actually run. And what's happening behind the scenes is that it runs 4 times only on machine number 1. It's because it's a typical, very small Linux command, and there's no need to actually jump that over to machine number 2. And that's how MPI works. So I'll stop the part 2 over here, and for part 3 we'll actually go into detail about how to write an MPI command and actually look through top to see the command actually be running on the second machine. So that's it for the setup for MPI on CentOS and on 2 virtual machines. When you want to exit the top is just a task manager. You just hit Q, and that's it. So thanks for watching. Hopefully you learned how to set up MPI correctly. Leave questions below, and stay tuned for part 3.